Hello and welcome to your test review video for exam 3 for MSU 152 College Algebra course. So we are making this video live in class, so there will be interactions with students. So I'll try to repeat questions that you may hear in class. Okay, so we're going to work through as much as we can through this review, and it'll probably take us a couple videos to complete it. Question 1, consider the function v of x equals -4 times the fourth root of x. Indicate the general shape of the graph. Click any graphs to make your selection. Which of these, a fourth root, what does a fourth root of x look like on a graph? Choice 1, 2, 3, or 4, what do you think? Plus. Well, what's choice 1? What kind of graph is this? It's quadratic. It's a parabola. That would be from x to the second power, or it could be x to the fourth power if it were flattened out on the bottom. You guys remember that polynomial function where the degree is even, is where both ends go the same direction. Okay, the second one, does anybody remember the type of graph that is? Greatest integer. So it has that symbol, the greatest integer function. Okay, what about the fourth one? What type of graph is that? It's a polynomial function, like a cubic, x to the third, okay, or x to the fifth, or x to the seventh, x to an odd power. This one is like a square root or fourth root function, which clearly here is a fourth root function. And notice that this has been reflected. It has been reflected because we have that negative in the front of the function. So instead of a fourth root function would look like this, but the reflection of that when it's negative looks like what is indicated here. So our correct answer for the first part is the third choice. Okay. Yes. Okay, part 2. We're talking about the same function. It asks us to plot 2 points on the graph other than the origin. Okay, so this is where I say pick a number, any number, but pick a number that is going to be easy to work with. So it says don't use the origin, so I may substitute in the number 1. So if I choose 1 for my x coordinate, and I substitute in a 1 here, fourth root of 1 times -4. The fourth root of 1 is 1, and 1 times -4 gives me -4 for the y coordinate. Pick a second number. I believe here it's going to ask me to pick numbers that fall between 0 and 10, or -10 to 10, because of showing up on this particular graph. So if I were just going to pick something, I would pick something that had a fourth root, like 16. But 16 doesn't show up here. So I may just pick the number 2. And it says I can round off to 2 decimal places. So if I substitute in a 2 for my second number, I would take the fourth root of 2 and then multiply by -4 and round to 2 decimal places. So does anybody have it? -4.76. Does anybody else get the same answer? Anybody? Please don't be afraid to speak because I'm wearing this funky headset. Y'all are scared. Okay. I'm going to double check it. Y'all don't make me do this every time, okay? Times -4. Yes. -4.7. It says 0.756, and the 6 rounds that up to a 6. All right, question 2, part 1. Consider the function. Indicate the general shape. Which general shape is this? The second one. Why? Absolute value. When you see these bars, you know you got a V shape. Negative in the front is what inverts it, makes it an upside down V. This one again is x to an odd power. This one would be the greatest integer function. This one is x to an even power. Okay, so we know those general shapes. I'm just putting them there to remind you of the different possibilities you could get. Any questions about that? Jimmy, questions?
I didn't know it was negative.
It was negative, yeah. I just wrote over it. That was the reason to be pointed down. Okay, next part, same question, plot 2 points on the graph other than the origin. So pick a number, any number. I like the number 1. So if I substitute in the number 1 here, negative 9/5 times the absolute value of 1. That would be negative 9/5 times 1, which is negative 9/5. Okay? Pick another number, any number. Here, I would choose negative 1 for my second number. So if I substitute in negative 1, because the absolute value of negative 1 is still 1, and 1 times negative 9/5 is still negative 9/5. So that is fairly easy to enter there. Okay, why did I not pick a negative number, by the way, on this example? You can't take an even root of a negative, yes. So you cannot pick a negative on that one. But here, positive 1 and negative 1 were a great choice. Does that make sense? Questions? All right, moving on. What am I doing? Yeah, here we go. The safe load L of a wooden beam of width W, height H, and length L, supported at both ends, varies directly. Pause. Varies directly. That is going to mean K times. As the product of the width and the square of the height, product of the width and the square of the height. Notice how I'm multiplying those. And inversely as the length. That means divided by the length. And this all is representing a load, a safe load, capital L. Okay, direct and inverse variation, the first step is to create a formula. The second step is to substitute in numbers and solve for K. The third step is to use what you found for K in the specific situation they're asking you to find. Okay? So step 1 was create this formula. All right, step 2. We're going to solve for K by substituting in the example information they give us. A wooden beam that is 2 inches wide, so I substitute 2 for W, 7 inches high, and notice the height has to be squared, and 144 inches long. So this is my sample information. So 144 goes here. Can hold a load of 20 pounds. So there is my substitution to enable me to solve for K. So the first thing I will do is multiply 2520 times 144, which is 362,880 equals K times 2 times 7 squared. Okay. Let's see, 7 squared is 49, and multiplied by 2, that is 98. So I could rewrite this as K times 98. And then divide both sides by 98 to find that K equals 362,880 divided by 98 is a big long decimal. I do not want you to round K. Do not round K. Make a note of that. Do not round K. I'm going to convert that to fraction form. Nope, it's not going to let me. Surely it will. Let's see. 362.80. 362. Has anybody converted that to a fraction? Okay, hold on. 362,880 divided by 2. They're both even. Is the same thing as 181,440 over 98 divided by 2 is 49. So that's just reducing by a factor of 2.
So what if we didn't put it into a fraction?
If you don't put that in, if you use the decimal, use every single decimal. Every single one. Do not round to k. That's why I'm choosing to enter it as a fraction, because I feel like it's a little bit friendlier. You could use this for k, because it is correct.
So it won't count it wrong if we don't put it in fraction form?
This is not the answer. This is just something you're going to use to get the answer. The question was, will it not count it wrong if it's in fraction form? At this point, we don't have the final answer. We're just getting k. Okay? So I could use either of these two numbers that I circled, or I could use the big long decimal as long as I don't round it and use every single decimal that the calculator gives. Okay? For k. Step 3. Go back to the question. What load, so you're solving for L, what at the last step, not for k. You don't round to k. At the last step, you round to the nearest integer. Okay, what load would a beam that is 6 inches wide, 8 inches high, 168 inches long of the same material support? So k was this fraction. Let's see. K was, I'm going to use 181,440 over 49 times W was 6, the width is 6, right? The height that is given here is 8, so times 8 squared. And the length that is given is 168 inches long. Everybody see how that works? Okay, and now we just calculate this. So I may enter that fraction to get the decimal back onto my calculator. I just don't really want to have to type that whole decimal in. Okay, and then multiply by 6. And multiply by 8 squared. And your calculator should be able to perform all of that portion, the whole numerator, in one step. Which is 142,1897.143, all divided by 168. And I got L equals 8463.67347. Here's why we don't round until we get to the last step. So it's round to the nearest integer. So this is a 0.6. That's a 0.6. So I'm going to write my final answer as 8464. I don't want to round before I get to that, because what if my rounding early makes this a 0.4? If that made this, if that early rounding throws this off by 0.2 in the wrong direction, then I'm going to get a 8463 and my answer will be wrong. Okay? So do not round until the very end of this problem. Everybody understand? All right, let's move on. Can I move on? Okay. Next question. Hooke's law says that the force exerted by the spring in a spring scale varies directly with the distance the spring is stretched. If a 22-pound mass suspended on a spring scale stretches the spring 5 inches, how far will a 28-pound mass stretch the spring? Round your answer to 1 decimal place. That means in the last step. Step 1, create the formula. The force exerted, with Hooke's law, we call that force weight. So we're talking about weight. But if you don't get that that's weight and you put an F, that's okay. Okay, you just got to come up with the formula. Phi the spring in a spring scale varies directly with the distance that the spring is stretched. Varies directly means K times the distance that the spring is stretched. This one's quite a bit simpler than the last one. Okay, if a 22-pound mass, that is referring to the weight, 22-pound mass, 22-pound mass, suspended on a spring scale stretches the spring 5 inches. K times 5. Let's solve for K. We would divide by 5, and we would see that K is 22 over 5. And I'm just going to leave it as that fraction, 22 over 5. Okay? Then, what I'm supposed to find out is how far will a 28-pound mass, that's again referring to the weight. So that's going to be 28 pounds equals K times, you're supposed to find out how far it stretches it. So you're looking for the distance this time. K, I should have substituted my fraction 22 over 5 times distance. Okay? So what needs to happen here?
Divide by 22.
Sure, divide by 22 over 5. Or we could invert multiply if you're thinking about division by fractions. So 28 divided by 22 fifths, or 28 times 5 over 22, either way, you can think of that. So 28, I'm just going to divide by the fraction, 22 fifths. Okay, this one said to round to the nearest what? 1 decimal place. So the distance would be, I got 6.36. So that's going to round. The 6 makes that 3 round up to a 4. So 6.4 inches. 6.4 inches. There's our answer. Okay, moving on.
So 6.4.
6.4 inches, yeah. 6.4. It was 6.36, and then we rounded it. All right, question 5. Step 1 of 4. So this one has 4 parts. So when you take your test, you'll see 5A, 5B, 5C, 5D. Okay, consider the following function. Identify the more basic function that has been shifted, reflected, stretched, or compressed. Basically, take anything out that's not an x. And this is going to be x to the 3rd power is the basic function. Okay, so that's easy, part 1. Part 2, indicate the shape of the function that was found in step 1. So we're going to look at all these choices. Which choice is x to the 3rd? Anybody? Well, let's just name them all since we're reviewing. This would be x squared. This one is x cubed. This one is 1 over x. This one's 1 over x squared. This one is a square root of x, or an even root of x. This one is an odd root. It's like cube root of x. This one's absolute value, and this one's greatest integer. Because on the test, it could be any of the above, right? Okay, and this is going to be available to you on video, clearly, so you can go back and watch it. Do you think you should go back and watch this video? Probably. You probably should. Do you think you should turn the sound off and watch it? Yeah, that just hurts my feelings. Okay. All right, so the correct answer was the second graph on top row. Next part. This is part 3 of the same question. It wants us to identify how it's been shifted. So when we have something that is added to x right with the x, that is a horizontal shift. That's going to be a horizontal shift of left or right. Left. It's going to be left, and it's going to pop up a box to tell you, for you to tell how many units, I think. So left, how many units? 6 units. Remember, your horizontal shifts are opposite signs. Plus signs move it in the negative direction. Minus signs move it in the positive direction. Okay, stretch or compress. Is this one stretched or compressed? No, there is no stretch or compress. That comes from something being multiplied in front of the function. So for example, if I had a 2 in the front, I would say that is stretched. If I had a 1/2 in the front, I would say it is compressed. But this one had neither. Okay, x-axis reflection. X-axis reflection comes from a negative in front of the function, like that, which clearly this one does not have. So we will say there is no x-axis reflection. Y-axis reflection comes from a negative directly on the x. So in this case, a y-axis reflection would be like a negative right there on the x. So we do not have that either. Vertical shift comes from something being added or subtracted to the function at the end, or it could be at the very beginning, but it's not contained in the parentheses here. So do we have anything added or subtracted outside the parentheses? No. So we have no vertical shift at all. And what will happen as you enter these values? Your graph here updates to look like the graph that you're telling it to look like. Okay? Then you go on to the next part, and it asks us to state the domain and the range. It will allow you here to click on the previous answer, and it shows you a picture of the graph you chose here. It'll show you a picture of this graph. Okay? That's really helpful for domain and range, because in domain and range, I taught you guys to imagine for domain flattening it to the x-axis, and for range flattening it to the y-axis. So if I were to take this shape, and I flatten it to the x-axis so that it's horizontal on the x-axis, because of those arrows, it's going to go everywhere from left and right, from negative infinity to positive infinity. So I could say that my domain is all real numbers. I could also say if I smash this thing flat to the y-axis, the arrow is going up forever and down forever. It's also going to have a range of all real numbers. Now, would a parabola have a domain and range of all real numbers? This was a cubic. What if our graph had looked like this? What about the domain? The domain here, if I flatten this thing flat onto the x-axis, it would cover the whole thing. So the domain here would still be all real numbers. But what about the range? If I flatten this thing to the y-axis, it would cover from here on up. So it would start maybe like if this point were at 1, and then it would go up to infinity. So the range is not always going to be all real numbers on a parabola. And that's just one example of a different type of graph. Everybody understand how the domain and range works? Smash it to x, smash it to y. Okay, moving on. Question 6, step 1 of 4. So this is 6a. Consider the function, identify the more basic function. The most basic function, basically get rid of anything that's not x. There it is, the square root of x. There's the basic function. That make sense? Yeah?
Yeah, I just don't know what the problem is. Same. You just covered everything up.
Oh! She doesn't know what the problem is because I just marked it all out. Okay. Sorry. Okay. It's okay. Listen. Don't be afraid to speak up. Okay.
We can find out later.
Next part, it asks us for the shape of the graph. So we went through all these on the last one. What's the shape of this graph? Square root of x, which one?
Bottom left.
Bottom left, right here. Whoops. There we go. Next part. It wants us to identify the ways it is shifted, reflected, stretched, or compressed. So, is there a horizontal shift in this function? For there to be a horizontal shift, you have to have something added or subtracted from x right with the x, and that would mean under the radical in this problem. There is none. Okay, is this one stretched or compressed? Yes. We see a stretch because that number is greater than 1. It's stretched by a factor of, I'll ask me to give the factor of 2. Does this one have an x-axis reflection? No, you would have to have a negative in the front. So this one does not have a negative in the front. Does this one have a y-axis reflection? No, you would have to have a negative directly on the x. That would mean a negative under the radical here. And what about a vertical shift? This one has vertically shifted by 2 units down. So down 2 units. Okay, again, when you fill out this left-hand side, the graph here on the right updates to look like the graph that we should see for our next part, which is domain and range. So I'm just going to try to sketch this a little bit. This one's shifted down 2 units, and it is stretched a bit. So it's kind of going to look like that. It didn't have any reflection. So that is the basic graphic that it's going to update to look like, which helps us with domain and range. The next part asks me to state the domain and range. It'll let me click to see the previous graph. For now, I'll just flip back to it. If I were to flatten this thing to the x-axis, what portion of the x-axis is going to be covered here? Well, starting at the origin, everything to the right. So from 0 to infinity will be the domain. So including 0 and going to infinity. Okay, what about the range? If I were to smash the blue graph flat to the y-axis, it would start here and it would go up forever. So where is that on the, what y-coordinates are included? From where to where? From -2 to positive infinity. So the range is from -2 to infinity. Make sense? All right, moving along. Question 7, step 1 of 4. The same type of question. Do you think you're going to get 3 of these on the real test? No. Do you think we're just trying to give you a lot of examples on the review? Yes. Okay, so what is the basic function? Well,
Is that x minus 1?
I'm going to give it back just a second, but there it is. 1 over x squared is the basic function. Okay, so let me make it go away now. 1 over x squared. So part 2 is going to ask me to identify the shape. Which one of these is 1 over x squared? Top right, here it is. Oh goodness, what happened? Okay, we're still plugging in. We should be good. We're at 28 minutes and counting on our video. Oh my goodness. It's going to take forever to upload. Okay, there's the graph. Step 3. Let's talk about our shifts. Does this one have a horizontal shift? Yes, something added or subtracted with the x. What is our horizontal shift? To the right, 1 unit. Is this one stretched or compressed? It is not, but let me tell you what that would look like in this function, because these are a little funky. If this number here were a 2, then the general, the general function is still 1 over x squared. But the 2 would be the number we're multiplying by to stretch it. So then it would be stretched by a factor of 2. Okay? I don't think that it's that hard on the test, though. I think it's a little obvious like this one. Okay. So anyway, that one is not stretched or compressed at all. Oh, if it were compressed, it would look like this. 1 over, like the number there. Okay, so it's like 1/2. Okay. It's not stretched or compressed. Does this one have an x-axis reflection? Yes, because of the negative in front of the function. Does this one have a y-axis reflection? No, because there is not a negative directly on the x. Does this one have a vertical shift? Yes. Up 2 units. Okay, so if I were to graph this graph over here will update, but here's exactly what it's going to look like. The vertical shift is 2 units up, and the horizontal shift, which means your asymptote basically, is going to be moved up 2 units. Your horizontal shift of 1 unit right means that asymptote is going to be shifted 1 unit right. So your graph will look like this. You do it in purple. Your graph would be here and here. Okay, so if I were to smash that purple graph flat to the x-axis, it would go from negative infinity up to this right here, that vertical asymptote. And it's going to jump over that point, and it's going to start back here after the vertical asymptote and then go to positive infinity. So my domain, I'm just going to put it on this screen, my domain would be from negative infinity up to, where was that jump occurring? Where was the jump occurring? At 1 on the x-axis. Curvy bracket because it's an asymptote. It doesn't actually hit it. Union with, start back after 1 and go to positive infinity. There's your domain. Your range. If I take the purple graph and I smash it flat to the y-axis, then it's going to get really close here, but then it's all pointing upward. Got a left-handed problem here. Okay, it's all pointing upward, but its starting point is where? It's starting at 2, but does it actually hit 2? There's an asymptote there, so it's curvy bracket from 2 to infinity. Okay, so there was your domain and range. Oh boy, question 8. Step 1 of 2, here we go. For f of x equals x cubed plus 2 and g of x equals x plus 3, find f dot g of x. F dot g of x means f of g of x. So if my f function is x cubed plus 2 and my g function is x plus 3, I want you to see from this that the g function is going to go inside of the f function. F dot g means f of g. So here's how that looks. The g function is x plus 3. So this becomes, we are finding f of x plus 3. Since f was the outside function, I replace all my x's in the f function with the quantity x plus 3. So the f function said x cubed plus 2. And what goes into this is x plus 3. I really wish that we could enter that as our answer. See that? I need you to have to multiply this thing out. And it's cubed, so it's a binomial times itself 3 times. So it is a bear of a problem. Here we go. That means x plus 3 times x plus 3 times x plus 3 plus 2. We have to enter our answer in simplest form, so you have to simplify this. So I will begin by FOILing 2 of these. FOILing these 2, I get x squared plus 3x plus 3x gives me 6x plus 9. And I'm still multiplying by this x plus 3, and then I'm going to add 2 at the very end. Next, I will take this x plus 3, and I will distribute the x back to each of those terms of the trinomial. So that gives me x cubed plus 6x squared plus 9x. Then I will distribute the 3 back to each term of the trinomial. That gives me plus 3x squared plus 18x plus 27, and I still have this little lonesome plus 2. Last, I'll combine all like terms. So, x cubed has nothing to combine with it. We're done with it. 6x squared combines with 3x squared. That's 9x squared. And I'm done with x squareds. 9x combines with 18x to give me 27x. I'm done with those. And then 27 plus 2 combines to be 29. So f dot g of x, whew, is that? It's not horrible, it's just a lot of work. Okay, then it asks to state the domain of that. Well, look at the original functions. What's the domain of a cubic? All real numbers. Okay. What's the domain of a line? All real numbers. So when I put one inside the other and I look at the final answer, do I have any red flags here? Okay, when we're stating domain, we're looking for red flags in situations, any implied domain restrictions. So I don't have any red flags. The red flags come from x under a radical, or x under an even root, x in the denominator, or both occurring at the same time. X under an even root that's in a denominator. We don't have any of those things occurring here. The domain's all real numbers. So this was the function answer, and then here was the domain answer. Domain is all real numbers. We're going to stop there because the bell rings at 40. Wait, what time's the bell ring? 49? Okay, we got a few more. We got time for finishing this one. Okay, part 2. Determine the formula and domain for g dot f of x. If it wasn't fun enough for you one direction, we're going to go the other direction with it. G dot f of x. Okay. So g dot f, this is where we're going to find g of f of x. F of x was this, so we're finding g of the f function, x cubed plus 2. Alright, the g function was just x plus 3. So x plus 3, I replace x with parentheses. Then inside this parentheses, I'm going to input my f function. Interestingly, it's so much easier this direction. When I have to cube binomials, it's awful. But here, the cube is just on the x. All I have to do is combine these like terms. 2 and 3 combine to be 5. So g dot f of x is equal to x cubed plus 5. Do we have any red flag situations in the final answer? No. Do we have any red flags in the original problems? Nope. This is a domain of all real numbers again. I think I can get through this one too. Okay. This says to determine f plus g of 3. In order to do this, I first need to determine what is f of 3. The f function, if you'll notice, is a graph given up here as a red graph. And f of 3 means when I go to 3 on the x-axis, if my input is 3, what is the output of the f function? Well, the output is at 1. Okay? So here was 3. And the output would be 1. This is an ordered pair, 3, 1. So f of 3, f of 3 is 1. The input's 3, output's 1. F of 3 is 1. Now, let's find g of 3. G of 3, when we go to 3 on the x-axis, my g function output value is there. And that is at what? Negative 5. So g of 3 is negative 5. Or I have an ordered pair at 3, negative 5. So if I'm asked to find f plus g of 3, f of 3 is 1, g of 3 is negative 5. I add them. My answer is negative 4. Okay? Now, the next parts use the same graph. F of 3 was, what was it? 1 and negative 5. So this becomes 1 minus negative 5 when you're subtracting them, which becomes plus a positive. The answer is 6. Then this becomes f times g of 3, 1 times negative 5, which has an answer of negative 5. And the last one is f divided by g of 3, so that's 1 divided by negative 5, or the fraction negative 1/5. So all the work is just in determining what is f of 3, what is g of 3, and then add, subtract, multiply, divide. That's 4 parts. That's on the test. That'll be there. And I mean, that should be a give me easy points right there. Does it tell us how many points those are worth? 2 points each. So 2, 4, 6, 8. 8 points for that. Okay, we're going to stop here. And it's a 41-minute video. Yeah, and we're like halfway there. So I hope this helps you with the first part of your review. And good luck studying for your exam.